Okay, this is today's bell assignment. Please pause the video so that they can work on these on their own paper. When you're finished, please take a problem to the board, go over them together whenever you're done, and hit play on the video. What we're talking about today is lesson 74, solving absolute value equations. Okay? The absolute value of a number, n, is the distance from n to 0 on a number line. So we have the absolute value of -5 is 5. Because -5 is 1, 2, 3, 4, 5 units from 0. The absolute value of 7 is 1, 2, 3, 4, 5, 6, 7 units from 0. Notice that both of these are positive numbers because distance is not measured with negative numbers. It will always, absolute value is always going to be a positive number. If the absolute value of x equals 5, then x equals 5 or x equals -5. Okay? Both of those give us an absolute value of 5 because they're both 5 units from 0. Similarly, if x plus 2, or the absolute value of x plus 2 equals 6, then x plus 2 equals 6 or x plus 2 equals -6. And this is what's important for today's lesson. Okay? I'll go ahead and we're going to talk about some examples with that. So on A, it says the absolute value of x equals 4. Well, in that case, if I drop the absolute value bars, x has to be equal to 4 or x has to be equal to -4 because both of those give us an absolute value of 4. They are both 4 units away from 0. Now, whenever we're solving these absolute value inequalities, we're going to use this to solve. Okay, so just like I did in example A, I have the absolute value bars all by themselves on one side of the equal sign. I'm going to write two equations now, which without the absolute value bars. So I have that x minus 2 is equal to 10, or the other number that has the absolute value of 10 would be x minus 2 equals -10. Okay? This is or in between here. So I have to solve both of these now. So to get x by itself on the first one, I'm going to add 2 to both sides. Cancels. I'm left with x equals 12. Or on the second one, to get x by itself, I'm going to add 2 to both sides. Those will cancel, and I'm left with x equals -10 plus 2 is -8. Final answer. Okay? Whenever we do this, we have to set it whenever we drop those absolute value bars, we have to set it equal to numbers that give us the absolute value that they have shown. Okay? So on A, we have 3 times the absolute value of x equals 27. On a problem like this, we have to get the absolute value bars completely by themselves on one side of the equal sign before we can solve. So 3 is being multiplied by the absolute value of x, so since it's being multiplied, I can work it the same way. I'm going to divide by 3 on this side and on this side. 3's will cancel, leaving me with the absolute value of x equals 27 divided by 3 is 9. Now, there are two numbers that give us the absolute value of 9, and that would be x equals 9 or x equals -9. Both of those are part of the solution set. On B, we're going to do the exact same thing. Okay? I have to get the absolute value bars completely by themselves before I can solve the problem. So 5 is being multiplied by the absolute value of x plus 3. So I have to divide by 5 on both sides. What I do to one side, I must always do to the other. 5's will cancel, leaving me with the absolute value of x plus 3 equals 60 divided by 5 is 12. There are two numbers that give us the absolute value of 12, and that would be 12 and -12. So I'm going to write x plus 3, I'm dropping those bars, equals 12, or x plus 3 equals -12. So to get x by itself on the first one, I'm going to subtract 3 from one side. What I do to one side, I must do to the other. Those will cancel. I'm left with x equals 9. Or On the other one, to get x by itself, I have to subtract 3 from both sides. So my 3's will cancel, and I'm left with x equals negative 15. Okay, so both of those answers have to be listed for our solution set. Okay. Will that work? Yeah, jeez. Alright, I'll just have to rewrite B. On A, once again, to solve the equation, I have to have the absolute value bars all by themselves. So I have the absolute value plus 4. So I have to move that plus 4. Okay? So to move that, the opposite would be to subtract. What I do to one side, I must do to the other. Cancels. So I have x, the absolute value, excuse me, of x plus 3 equals 4 minus 4 is 0. Okay? So whenever I do this, 0 is just 0. There is no absolute value for 0, or 0 is itself, so it can't be a distance away from itself. So I'm not going to write two equations on this one. All I'm going to have on this one is I'm going to write x plus 3 equals 0. To get x by itself, or subtract 3 from both sides, it will cancel. X equals negative 3. Final answer. I'm going to rewrite this one up to the top. What I want you to do is I want you to solve this one on your own paper. So please pause this so that they can work on it themselves. Give them a second. When they're done, then you can hit play. Alright, so whenever we have a problem like this, we have to get x by itself. Okay, or get the absolute value bars by themselves. Okay, so I'm going to have to divide by 5. What I do to one side, I must do to the other. So I have the absolute value of x minus 2 is equal to negative 2/5. Now, I'm guessing that you probably went ahead and split it into two problems. You can't do that because this cannot happen. The absolute value is never going to be a negative number. So on a problem like B, there would be no solution. If before you drop those absolute value bars, it's already a negative on the other side of that equal sign, can't do it. Okay? No solution. Absolute value is always a positive number. The thermostat in a classroom is set at 21 degrees Celsius. The thermostat will turn on or off if the recorded temperature is plus or minus 1.2 degrees Celsius of this setting. What are the maximum and minimum temperatures for this classroom? Okay, so what we're going to do here is we have to set up our equation, and it is plus or minus, which means they're talking about the absolute value. Okay, plus or minus, so we can set that x minus 21, or the absolute value, excuse me, of x minus 21 is equal to 1.2 degrees Celsius. So I'm going to write it as plus or minus. So I set up my two equations. I have x minus 21 equals 1.2, or I have x plus 21 equals negative 1.2. Whoops, I didn't mean plus. Sorry. X minus 21. Sorry, it stays the same each time. I just wrote the wrong thing. Excuse me, please. Okay, to get x by itself, once again, I have to do the opposite. So I'm going to add 21. What I do to one side, I must always do to the other. So I'm going to add 21 over here. Cancels. I get x equals 22.2 degrees Celsius. Or, on the other side, once again, it's subtracting, so I have to add 21 to both sides. Whoops, I wrote the wrong thing. Dyslexia, sorry. I add 21 to both sides. So 21s will cancel, and I have a negative 1.2 plus that 21. I will get x equals 19.8 degrees Celsius. Okay, so if the temperature that's recorded is 19 degrees Celsius to 22.2 degrees Celsius, 19.8, excuse me, to 22.2 degrees Celsius, then the thermostat will turn itself off. If it falls outside of those parameters, then it's going to kick on the furnace or kick on the air or whatever it is that is going on. Okay, this is your homework for today. I want you again to do the practice set and this right here from lesson 74. If you're talking, the homework is going to be changed to all of the problems. Please get your homework done. It will be graded as soon as you walk into the room tomorrow. Have a good day. Be good.